In this video, we're going to look at some additional examples for functions. There will be three functions in this program. A simple one is going to be to add two numbers and return the sum. The second one is going to convert a temperature from degrees Celsius to Fahrenheit. And the third one will compute the body mass index. Remember that with functions, you need to have three parts. So let's scroll again to the bottom. So this is the end of the main program here. And we'll put the body of the functions down below the main program. So I already have comments here for function add2 and the other two functions that we're going to write. Convert temperature, body mass index. So we'll put the body for those functions here as we move along. Also recall that at the top of the program we must always put our function prototypes there above main. So we sort of make a sandwich with main in the middle, then the function body and prototypes as the bread on each side. In order to access the functions, we must put a function call, and I've left that blank for the time being. This program already has a number of variables declared. So we have the variable answer is just going to be used to allow us to repeat the program. We have some f num1, f num2, and f sum, which we'll use for our add2 program. We have the weight, feet, and inches for the body mass index, as well as another variable BMI of type double to go with that. And for the temperature table, we have a double temp C and temp F. This program is going to allow us to call these, to run a program repeatedly or call the functions repeatedly. So I have put a do-while loop around test case 1, and we'll do that for test case 3. We'll do something different for test case 2. So here's what we have. We're going to just print to the screen. We're going to test function add2 with some real numbers, and we're going to ask you to input those. So we'll have a printf to prompt you to enter two floating point values. We'll read those in with the scanf, and then we'll call that function here. When we are finished with that, we are going to give ourselves the option to call the function again with two different numbers. So that's what this do-while loop is all about, and you've seen that on earlier videos. All right, well, before we look at the other functions, let's take care of the add2 function. Let's go write the function body. So scroll down. And here are the comments for that. So we have function add2, and if we're going to add two numbers, we have to have two arguments to accept those values. And in the description for the function, I'm just calling those first num1 and first num and second num. And then my comments indicate that this function is going to return the sum as a type double. All right. Now recall that when you're writing a function, you have to give it a type and a name. And this tips off what type the function has to be. Okay, the type of the function has to be the same as the type you want to return from the function. Okay, so this is going to be a type double. And the function is going to be called add2. And we need to, we can't put a space there, so we'll just put those together with an uppercase T. So let's do add2. And the function is going to need two dummy variables. That is, two locations or variables to accept the two numbers we want to add together. Okay, so those are going to be double, and I said it's going to be first num. Okay, so we have to give it a type and give it a name, and the second argument is similar. Okay, we have a double second num, then right paren, and let's put the curly braces in for the body of our function. Now, within this program, you can also declare some additional variables if you want to. And since we're going to be computing the sum and returning it, I'm going to declare a variable for that. So let's make it double sum here and set that equal to 0.0. All right, now we will come back to this in the future, but this variable that you declare within the curly braces of your function, this is called a local variable. And it's to be used only within this body of code, only within this function. That means that if you have another function somewhere, or if you have the main program and it also has a variable called sum, then it will not interfere with this sum that we have here. Okay, so that's very important. all variables declared within the curly braces of a function have visibility that is only within this function. This variable will not interfere with any other variables in other functions or the main program that has the same name as sum. So you don't have to worry about that. Okay, well, this is a simple calculation, right? So we just do sum is equal to first num plus second num. So very simple calculation. There's a semicolon. But this is just to show you the mechanics. Now, once we have completed the calculation, we want to return the value from the function using the return. And we give it the name of the variable that we want to return, and that's going to be sum, and we use a semicolon there. So this is a very simple function. Okay, it's going to input two values. It's going to add them together and store the answer in sum, and then the function is going to return the number sum to the main program. All right. Now let's do the other parts of our function. So we want to have a function prototype, so we'll highlight the first line of the function. I'll copy that with Control-C. We will scroll to the top and we will paste that in at the location where we put our function prototypes, and we'll add a semicolon. In order to call that function, we have to put a call to it here. And the way I'm going to call the function this time is I've got a variable called fSum here. Okay, it's a type float. Okay, it's a type float, but don't worry about that. You'll see that this will work out okay. Okay, num1, fnum1, and fnum2. Okay, those are also type floats. All right, so there's a little subtlety here. These are float values, but the function itself is a type double, but that will not matter. Okay, so I'm going to call the function, and I'm going to save the answer in fSum. All right, so here we go. Okay, fSum is equal to add 2. And I want to add the two numbers that I just input. So that's fnum1, comma, fnum2, right paren, semicolon. Okay, so we're going to call function add 2 with these two values. All right. So when you input the values for fnum1 and fnum2, you type in any two numbers that you want. Then we're going to pass those two numbers into the function add 2. It will do a computation and it will return the value, and we're going to save that value in this variable here called fSum. All right, so now to see what we have, let's have a print statement to print out all of these values. So let's do this. Okay, printf. Okay, double quote the sum of, and these are floating point values. So let's do a %6.2f and another %6.2f. So we're going to say the sum of num1 and num2 is another %6.2f. Okay, \n. Okay, double quote, comma, and we're going to print out I can't type it, fnum1, fnum2, and fSum. All right, so that should take care of it. So here's the call to the function. We're going to input a couple of values, and we'll call the function, and we'll print out the result. And then we have our while loop, and we can add more if we want to. All right, well, given this, let's build our program and run it to see what we get. Okay, the program has finished building, so let's run. And here's our output window. Okay, so we have entered our loop. We are going to test function add 2 with real numbers. All right, so this will be easy. We're going to just type in a couple of numbers. So let's do 3.18 and a space, and let's do 6.25, and I'll hit enter. And we get the sum of 3.18 and 6.25 is 9.43. And if we want to do some more numbers, we can enter 1, or we can stop with a 0. Okay, now notice what happened. Okay, we typed in the two values here. We called function add 2, and we sent it those two values. So let's scroll down to function add to. So the numbers that we typed in, the first one was sent to the function and became the variable first num1, or that variable recorded that number. And second num went here, our second value went there. Then we just did an addition to get the two added together, and we returned that value back to the main program. Coming back to the main program, then after this function has finished, we move on to the next line in main, and that just prints out the value. So we have the two numbers that were input and sum, fsum, which was recorded from the function that we called. All right. Now we still have this running, so let's do one more example. Make it a little bit bigger. Do you want to add two more real numbers? Yes, let's do 1. And we'll add our two more floating point numbers. So let's do 5.555. And let's do 2.222. It's easy to remember those. So we call the function, and they're added together, and we get 7.78 because we used our f6.2, which rounds, so we get 7.78 as our output. All right, so that illustrates how we can use function add to, and I don't want to do any more of those, so we'll just hit 0, and we'll close the window. Now let's move on to test case number 2, where we're going to write a function that will convert temperatures. Okay, so here we have test case 2, make a temperature table using function convert temp. And we're going to do a testing function convert temp. All right, now in this case I'm not asking for any inputs. We're just going to use the function to generate a table of temperatures in Celsius and Fahrenheit. All right, so let's go ahead and type some preliminary stuff for that. For the headers, we'll do a printf, okay, a double quote, and let's use Celsius, a couple of tabs, and Fahrenheit. So this is our column headers, \n, double quote, right parent, and semicolon. And then we're going to have a loop that's going to generate the table. But we'll come back to that after we generate the code for the function. All right, scrolling down, we are going to now put the code for function convert temp right below the function for add to. This was pretty simple. We just have one input value, which is temperature in Celsius, and we're going to return the temperature in Fahrenheit. All right, so it's going to be a type double, again, which tells us our function needs to be double, and the name of our function is convert temp, written like that, and it has one input value of type double, and that's going to be temp underscore C. Or let's follow my comments up there. Let's call this C underscore temp, except I'm using lowercase right there. Okay, and then we'll have the body. All right, internal to this function, we are going to calculate the equivalent temperature in Fahrenheit. So let's do a local variable here, double f underscore temp, and let's just initialize that to 0.0 to begin with. Now we'll do our simple conversion, where we have f underscore temp is going to equal to 9.0 divided by 5.0 times C temp plus 32.0. Now I always like to use, for these numbers, when I'm doing a real or a double calculation, to make sure that these are recognized as real numbers, and the divide itself is a real number. I like to use those. And this whole thing, f temp's a double, so I like to just make sure I always got a decimal point in my equation. Okay, so that is all we need to do. Then we just return the value for f temp and semicolon. Now, I want to show you an option that you can do with the return. In some cases, you're going to see the return in parentheses. Okay, that's one style that programmers like to use. It doesn't matter. So if you want to put your return value in parentheses, you can, or you can leave them off if you want to. So whatever style you prefer. So that completes this little function, which is hardly more involved than our add to, but it's going to do a temperature conversion this time, which might be a bit more useful. So let's make a copy of our first line for our function prototype, and we'll paste that in up at the top where the function prototypes go to live, and we'll add a semicolon. Alright, then maybe I zoomed away too quick on that. So here we have the two function prototypes for the two functions that we've done so far. Test case number 2, main program. We want to have a loop here to generate a temperature table. So let's just arbitrarily set our beginning temperature to say 0. So let's do this. 4, and what are my variable names here? Temp C and temp underscore F are in the main program. Okay, 4 temp underscore C equals 0. Let's start with that. And temp underscore C is less than or equal to, let's go to 100 degrees, boiling point of water. And let's just add on 10 each time. So temp C plus equals 10.0. Okay, so we'll make a table like this. All right. Now, in order to do the conversion, we don't need to do it in here because our function is going to do that. All right. So, in order to generate our table, we can embed the call to the function in a print statement. All right, so watch this. So we're going to do a printf, and the only thing we need to print here will be the values for temperature C and the temperature in Fahrenheit. Okay, so this is a double quote, and this is going to be type C, temp C. Let's look at that again. I think that's those are type doubles. All right, those are type doubles. So we need to do a percent, and let's just do a 5.2 LF. Okay, LF is long float or double. A couple of tabs, and I think I'll make this a 6.2. Yes, percent 6.2 LF. 2 tabs, another percent 6.2 LF. So that'll be the Fahrenheit. \n, double quote, comma, and we'll print out the value for temp underscore C, and that's not new. But to get the value, the equivalent value in Fahrenheit, I'm not going to put a simple variable out here. I'm going to call the function convert temp, and I'm going to pass into it the current value for temp C, and then a right paren and a semicolon. So what will happen here is that we are going to call the function convert temp, and we'll send it the value of temp C, which goes 0, 10, 20, and so on. The function is going to calculate the equivalent temperature in Fahrenheit and return it. So this will be the equivalent of the temperature in Fahrenheit. So again, let's look at the function. Okay, so it just takes temperature C, gives you an equivalent temperature F, and it returns it. So whenever you reference this function, then you're going to get back this one number, this F temp value. And we're going to call that repeatedly in order to generate a table here. All right, I need to put the closing bracket on the for loop, and let's take out a little space here and here. So that's all we need. All right. So the function itself will compute the Fahrenheit temperature. Okay, let's build this to see if it works. Okay, the function has, our program has compiled successfully, so let's run it. And here comes our output window. All right, so we still have the first test case for the add to function, so let's just put in a couple of values for that. Let's do like 2.5 and 5.5. I can't type. 2.5 and 5.5. There we go. So we get the output from the add to function, and no, I don't want to do another one. I want 0 to go to test case number 2 for the temperature table. All right, so here's the output then. So we're going to say we're testing the function, and we'll print the headers, and then we'll go into the loop and we'll call that function repeatedly. And here you can see the output. So in this case, our little for loop did generate a nice table of Celsius and Fahrenheit temperatures, where we used the function convert temp to get the values for Fahrenheit in each case. Now, let's finish up with another example of body mass index. So I'm going to close this window and stop the program, and we'll do the body mass index calculation. Okay, so let's scroll down, And let's write the body of our function for body mass index. All right. So this one, let's correct the typo there in the comments. So this is going to return the body mass index as a type double. So we'll go with that. And in this case, we have three input variables: the height in feet and inches, which is an unsigned integer, and the weight, which is going to be in pounds, and it's a type double. So the function returns a double. So we need to make sure that that is the correct type. And I'm going to use uppercase, or what do I call this this function? Well, I do have a variable called body mass, or BMI, capital BMI over here, but I'm going to use that differently in the main function shortly. So I'm going to name my function lowercase BMI, and you know, C is a case-sensitive language, so these will be two totally separate variables. Okay, so down here, I'm going back to our function, double lowercase BMI. And we need to have the three input parameters. So we need an unsigned integer for feet, and unsigned integer for inches, and a double for weight. So we need to declare those here. Unsigned int, and I'm just going to use the abbreviation or short variable for feet is ft. Another unsigned int, and let's call it n for inches. And then we have a double for weight, and I'll just use the variable weight here. Okay, inside the function, we are going to calculate the body mass index and return it. All right, so let's go ahead and declare some local variables. I know I have to compute the height in inches, so let's do an unsigned integer height, and let's set that equal to 0. And I need to calculate body mass index. So let's do double, and let's spell this one out. Okay, body underscore mass underscore index. And let's set that equal to 0.0. All right, now we can do the calculation. So let's calculate height. Height is just equal to feet times 12 plus inches. So we get the height in inches like that, except it's in, not the word inches. All right, so we'll do that calculation. Now we can calculate the body mass index. We have the variable for that. Okay, body mass index. And that's just equal to the weight divided by the height in inches squared. So let's do paren pow, and this will illustrate something as well. Pow of height, comma 2. And so that's height in inches squared, and then the entire thing times 703 semicolon. And that's our value we want to return. So we'll return body mass index. Right. Okay, so this one we have the function pow is shown here, and it does have red underneath it. So let's see if I've got the standard library up at the top. So I do. So this should be fine. So we're using the pow function down here, and that's fine. It'll compile just fine like this. All right. So that constitutes the function for body mass index. So now let's do the other two pieces. Let's take the first line for our function prototype, and we'll copy that. And we'll paste it where the function prototypes go, up at the top, way up here. And don't forget to add the semicolon. Now, in the body of our program, in the main program, we already have the code where we're asking for inputs for the feet and inches, and we have the input for the weight. So now we just need to call our function body mass index. All right, now if I'm going to collect the answer from the function, I need to have a variable. And the variable that I'm using for that is uppercase BMI here. Right? So I am going to do body mass index uppercase is equal to lowercase BMI, which is the name of the function. And I need to send it the height in feet, the height in inches, and the weight. All right, so we put a semicolon after that. So here's the call to the function. So we're going to call function BMI. The function will do its calculation and it will return the value for body mass index, but we then collect that return in this other variable, uppercase BMI, which is a local variable to the function main. So we're almost done. We just need to print out the result. So let's do printf, okay, double quote, and let's print out the inputs first. Okay, so let's do this. Okay, for a height of, and let's do a %u. We have an unsigned integer for height. So let's see, for height of %u feet and %u inches with weight of, and that's a type float, so let's do a percent 6.2f. Okay, then let's do a \n, double quote, comma, and we'll print out the feet, inches, and weight, right paren, semicolon. And then on the next line, let's do another printf and a double quote, the body mass index is, and that's going to be a type double. Body mass index is, let's do a percent 6.22 LF, long float or double, \n, double quote, comma, and BMI. That's uppercase. We collected the value BMI here from the function, so now we're going to print those values out. Now, given all that, let's compile the program and see if we have any errors. Okay, there were no errors, so now let's run the program. And we have to move past the first two test cases to get to the body mass index function test case. So let's do add 2, so let's do 3.5 and 4.5. So we get the sum of those. We don't want to do any more, so I'll type 0. In test case number 2, we still have the temperature table. Then the next thing we have is our testing function for body mass index. So we enter our height in feet and inches. So let's do like 5'8". The weight in pounds, let's do 180. And then we have our output. For a height of 5 feet and 8 inches with a weight of 180, the body mass index is 27.37. All right, so in this case, we have called our body mass function to do the calculation for us. So looking again at the main program, we have the inputs for height and weight. We call the body mass index function, lowercase BMI. We give it those three values, feet, inches, and weight. Scroll down, and you can see that the three values are accepted by the function in its local variables, feet, inches, and weight. Then we do the calculations that we need to inside the function for the height and then the body mass index. We return the body mass index to the main program. Then the main program can do what it needs to do with that return value, which in this case we're only printing out the final result. Right, so here's the call to the function. And then we print out the result that we've saved from the function here. Okay, now that gives you 3 more examples of how to use functions in the C programming language. And one more time, just a quick one last review. You do the body of your functions first, or you don't have to be first, but typically you do these first and they all go below the main program. You must have a function prototype at the very top, which is just the first line of your functions. And don't forget the semicolon. And in order to use the function, you have to call it. So here's an example of calling function add2. Here's a different method of calling the function where we're calling convertTemp within the print statement. And finally, for the body mass index, we have the more conventional call to the function where we call the function, we save the answer in the uppercase BMI. All right, well, that concludes this video for sample functions.